Today our topic is what is Chomsky's normal form for particularly type 2 grammar. There is another form of this kind of form, that is Kuroda's normal form in type 1 grammar, but let's today discuss Chomsky's normal form in the type 2 grammar. So Noam Chomsky, this cartoon actually explains that how Noam Chomsky found it that every language, any English, Bengali, French, Bengali, German, all languages, there basically some innate rules are there, that is published in the paper, syntactic structure, that some rules are inbuilt into the in the particular language. The child automatically learns that rules innately by the age of 2.5 and 3 or 4 years, and they can speak. So that is Chomsky found this single-handedly found this kind of grammar. Most simplest is type 3 grammar, regular grammar. The rules are like this. And type 2 grammar, context free. We are discussing today context free grammar. Left hand side should be a single variable. Right hand side can be any damn string. It can be a mix of variables or non-terminals and with the terminals. Remember, most of the books with variables is some non-terminals and variables. V or sometimes non-terminals signified by F. And Chomsky said that every rule should be like this. This is the left hand side, should be its variable, and right hand side should be either two variable or only one terminal. And that simplifies the rule that we can see that it is a binary tree, and we know that for computer science, so if then else structure or any tree implementation is very easy, and in linked list, and so that if all the grammar rules we can convert it to Chomsky's normal forms, then we'll found it with exactly, if there are n symbols in a string, with 2n minus 1 steps we can find it that whether that strings come from a grammar or not. That is a very good upper limit, that is 2n minus 1. We'll see it. We'll go to the next screen. Here we say that in CNF every derivation we can 2n minus 1 step, that's the maximum. That we cannot guarantee in other context-free grammar other than Chomsky's normal form. There is other form, Greibach normal form, we will discuss it later, but Chomsky's normal form, but any it guaranteed that is 2n minus 1, it can be done. But in any other CFG, not other Chomsky's normal form or like this, you cannot guarantee that you maximum you can need 2n minus 1 steps. This is Chomsky's normal form. At most 2 branches, that is good for computer science implementation in programming. It can be a binary tree like this. And the first thing for simplification, how is CFG simplified to be context-free grammar? The first thing we have to notice that we have to first make this 0th step, remove unreachable variables or non-terminals. We always use variables or non-terminal, but some of the books say maintain variables as V and non-terminals as N, so they are basically same. And here we can see that there are some rules which is cannot find. We can see this, like B is useless because nothing is derivable from this. So B, you on the right hand side the B is there, left hand side no such B. So you have to strike off B. You have to strike off the B here, like you have to strike off B. No rules. F is useless because if there is no such derivable from S, like here you can see the F rule, you cannot reach from S. So F is there. So both this, any rules B and F, we can safely delete. So first step is a 0th step, remove unreachable variable or non-terminal. Then there come a new start symbol and eliminate all epsilon rules. You take one epsilon rules, take at a time. Then it may generate other epsilon rules, you generate one at a time. And then unit rules, mixed rules, and long rules. So we'll go one by one. This is, I'm taking this example from Michael Simpson's book. This is the original grammar, and here no such variable is there which is unreachable from S, or there is no derivation. So 0th step is not relevant here. because AS is on left side, AS is on right side, so it is always prescribable. You should not prescribe mandatory. You have to take A0 in the starting variable. Even if AS is not in the right hand side, then it cannot generate long generation. So always is the mandatory. You have to take the new start symbol. Why I am taking new start symbol? We are taking, because whenever take a new start symbol, we know guaranteed there is no other S0 here. So that is the logical conclusion. Then after this first step, then you remove B to epsilon, and this B to epsilon, when you first go to B to epsilon, not try to B to epsilon and A to epsilon together. You should delete one rule at a time. You B to epsilon, then all the places B is there, you can put epsilon. So that is that the epsilon is there. EB, so it is a rule come A, B and A, both is there. B can sometimes go to epsilon, sometimes AB, both. So this is the stage number 2. Then we eliminate unit rules. So we remove this. Then we can come to this, and all this there in the attached document. And this is after we have come to this. And then whenever you see this kind of many variables, then we should make this SA to a different variable. So we can put it S to SA. So there we can put A1 instead of SA. So whenever there are long term variables, so we put like SA to A1. So this is the next conversion. This is a final CNF grammar. You can check it. We can add some extra symbols like U, A1, like this. It is not there. So first of all, it is from original grammar only 1, 2, 3, 4, 5, 6 rules. And here we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. More than around 16, 17 rules. The number of rules increases, but this is more simplified grammar for computer program, like parsing or checking whether particular string belongs to this grammar. So it's a much simplified grammar for computer, but it looks simple, but it is not actually not simple that way. Here we can go for any string with n, we can maximum 2n minus 1 steps. So we can say if that string is generated from this grammar. There is another example. This example is also given. We can take a S0 start symbol, then we eliminate new start, then all epsilons will added together. It is an attached document with you, so we can, with this presentation, we can see it. So there the same example. Then we just give an introduction at Greibach normal form. I have mentioned the one form is Chomsky's normal form, left hand side single variable, right hand side two variable on one terminal. Another form is Greibach normal form, which is very helpful for top down parsing. Like right hand side should start with one terminal and rest of all should be all variables, maybe 1, 2, 3, 4. There's no limit, but it should start with one terminal, one and only one terminal only, and left hand side all, right hand side all variables, or it can have only one terminal. So this is the form. Not Chomsky says there is a 2, so we cannot take advantage like binary tree. This is a Greibach normal form, but this normal form is very good for top down parsing. And this is if it is a grammar, you should take it a new variable d is equal to bc. So it is now in the Greibach normal form, but it is not in Chomsky's normal form. But it is not the Chomsky's normal form. So, but everywhere you cannot put any grammar to Greibach normal form easily. It is always advisable any grammar to first Chomsky's normal form, and from Chomsky's normal form to Greibach normal form. Greibach normal form are good for parsing. It is for top-down parsing. We will see that. What is that? Next, some questions. What is the time complexity of converting CFG to CNF? It is ONQ. Can every context-free grammar? Yes, it can be done. Every context-free grammar can be converted to CNF. Thanks for reading.